This stats homework is impossible. I need some help. I should call my professor. Maybe he can help.
Hello, this is Professor Tony. You need stats help on confidence intervals? On my way. Alrighty, I am here to help. Let's get started. Are you ready? Alright, so today we're going to talk about confidence intervals. So to do a little quick recap, as we've studied before, point estimates are our best guess for a parameter, and that gives us a single plausible value for the parameter. But the issue we run into here is that point estimates are rarely perfect.
Well, if point estimates are really perfect, how do we know what the actual value of the parameter is?
Great question, which leads to my next point. Rather than just giving a single point estimate of a parameter, we give a plausible range of values for the parameter, which as we know is called the confidence interval. So your textbook actually gives a really great analogy. So using just a point estimate is like fishing in a murky lake with just a spear. As you can imagine, that'd be quite difficult, and chances are you probably won't actually get a fish. So using a confidence interval is more like using a fishing net. Well, you'll more than likely catch an array of fish, and it'll be a lot easier to catch that fish as well.
So basically what you're saying is, by using a confidence interval, we're trying to capture the range that the actual parameter is in?
Correct. And you'll see what I mean later on when we work through our example problems. But back to point estimates. So it is the most plausible value of the parameter, as we mentioned before. So it would make sense to build our confidence interval around that point estimate. So we will also need a standard error, which is the measure of uncertainty associated with the point estimate, to help guide us in determining how large or how small our confidence interval is going to be. So if we want to find, for example, a 95% confidence interval, we know that 95% of the time it will fall within 2 standard deviations. If we want to find an approximate of 68%, that will fall between 1 standard deviation. Or if we want to find 99.7, a 99.7 confidence interval, that will fall between 3 standard deviations. That's the 68, 95, 99.7% rule, as we already know. Alright, so this is the example we're going to work on, and I will read it in case you can't read it. The National Survey of Family and Growth conducted by the CDC gathers information on family life, marriage and divorce, pregnancy, infertility, use of contraception, and men's and women's health. One of the variables collected on the survey is the age at first marriage. The histogram below, I don't actually have a histogram, shows the distribution of age at first marriages of 5,534 randomly sampled women between 2006 and 2010. And the average age at first marriage among these women is 23.44 with a standard deviation of 4.72. So in order to calculate our confidence interval, what we need is some sort of formula. So the formula that we're going to use is point estimate plus or minus 2. And we're using 2 because we're conducting 95% confidence interval, which we know is 2 standard deviations away from the mean. Since we know that, we can automatically plug in the 2. And we're going to use the standard error as well. When it comes to a problem like this, what I'd like to do is write out all the variables I have. So we know our sample size is 5,534, so we can write that down. So we have 5,534. We know the average age of marriage among these women is 23.44, so we know that's our sample mean, 23.44. This is also our point estimate, and then our standard deviation is 4.72. So let's write that down, 4.72. But in order to calculate the standard error, we have to do another formula. And the formula for that is very simple. It is the standard deviation divided by the square root of the sample. So plugging that in, that's going to be 23.44 divided by the square root of 5,534, which equals, write it down, 0.06. All right, so now we have our standard error, and we have all the parts we need to plug it in into our point estimate. So our point estimate, we're going to plug in 23.44 plus or minus 2 times 0.06. Alright, so we have 23.44 plus or minus 0.12. So once you do the calculations out for that, it's going to equal 23.32 to 23.56. So that's going to be our 95% confidence interval for this problem. So the way we interpret that is the researchers can be 95% confident that the population mean age of women at their first marriage is within our confidence interval, our 95% confidence interval of 23.32 and 23.56.
Well, what if we want to find the confidence interval that isn't within the 68, 95, 99.7% rule, where we don't know how many standard deviations away from the mean it is?
Oh, great question, and I can answer that working through this next example problem that I'll put up on the board. So let's say we want to find a 98% confidence interval for the population mean height of US men based on a study of 75 men. And the sample mean in our study is 70 inches and the population standard deviation is 3 inches. So we're going to use a slightly different formula that we used in our previous example for the 95% confidence interval, because 98 doesn't fall in that rule that we talked about earlier. So the formula that we're going to use this go around is point estimate plus or minus the z-score, which we'll get into to figure out how to find it, times the standard error. So why don't we just write down what we have? So we have the sample mean in our study 70 inches, so we can write that down. And the standard error is actually already given to us, which is 3 inches. So what we need to do is we need to find the z-score. So in order to do that, let's draw a bell curve. So I will draw it over here. So we split this up, and then here we have our 98%, and then this tail we have 0.1, and then this tail we have 0.1. So in order to figure this out, you need to look at the tables that I have given you. And if you look at the tables, you'll find that 0.01 closely corresponds to negative 2.33. It's not exact, but it's the closest value we have. That equals to 0.01, which is negative 2.33, which is going to be our z-score. So now that we have the z-score, we can go ahead and plug this into our formula. So our point estimate, we know, is 70 plus or minus negative 2.33 times 3. And so then we can go ahead and calculate that out. And so we will get we will get 63.01 and 69, or excuse me, yeah, 76.99. Sorry about that. And so you can go ahead and just round that up. So it would just be 63 and 77. So this equals our 98% confidence interval, and I just went ahead and abbreviate that. So my question to you is, how would we go ahead and interpret this?
We would interpret it as we are 98% confident that the population mean height for the US men falls within 63 and 77 inches.
Great, it really seems like you are understanding this, and I really hope that I was able to help you out on your homework assignment.
Thanks, Professor. You were a lot of help, and I think I can finally do this homework. Next, I have to ace the final.
Good luck!